Hi everyone, I'm Raúl Fernández-Díaz. I'm an industrial PhD candidate at University College Dublin and IBM Research. And I'm here today to present my work on an open source library for democratizing peptide machine learning called AutoPeptideML. Before commencing, I wanted to thank the organizing committee for giving me the opportunity to share my research and all the co-authors that have made it possible. So what's AutoPeptideML and what is its goal? So AutoPeptideML is a library for democratizing peptide machine learning. And what does this mean? The idea is that AutoPeptideML will help empower experimental scientists to build their own custom models based on their experimental data. And not only to build the models, but to integrate them into their experimental workflow, with the goal in mind of creating this feedback loop where the model, the predictions from the model help inform the new experiments, and the new experiments help improve the model. As a bit of background on peptide science, there are two main classes of peptides that we are interested in. The natural peptides, which are just the small protein sequences and are really cheap to manufacture. And this is important because that makes them cheap to experiment with. On the other hand, we have synthetic peptides, which are more complex and more expensive. But they have better pharmacological properties and are therefore better drug candidates. So AutoPeptideML, the first version, was built to support natural peptides just because there's where most of the publicly available data is. But we have extended it recently to synthetic peptides and peptidomimetics. And the reason why we decided to make this extension is that we had this hypothesis, this idea of what if we use the data from the cheaper experiments that are more easily to acquire with the natural peptides to train the models, and then use the predictions from those models to prioritize the most promising candidates for the more expensive experiments, thus saving, hopefully, money on the experimental part. So the first part from the computational point of view was to build a pipeline that is robust to these two data types, sequences for the natural peptides and molecular graphs for the synthetic peptides. And I will not get into the specifics, just to say that it was a fair amount of work to make everything to work simultaneously with two heterogeneous data streams. Finally, we tested the hypothesis of whether we can build models on natural peptides and then use them to extrapolate to synthetic peptides. And the short answer is that we can, with model performance around 35%, which is less than you will get in interpolation, which was reasonable. And one surprising thing that we found is that we compared different machine learning techniques, and we found that the traditional methods on cheminformatics that have been there for the last 30 years are better than more advanced language model techniques on protein, small molecules, or peptide language models. And with this, I just want to leave you with 4 takeaway messages. The first one is that AutoPeptideML exists, and that its purpose is to empower experimental scientists to build models. Second one is that we have extended its functionality to synthetic peptides and peptidomimetics, that we have a command line interface and a web server to facilitate its access and compliance with FAIR principles. And finally, that the whole goal, the whole objective is to reduce experimental costs. And with this, the presentation has been short and I have covered the topics superficially, but if anyone is interested, I'll invite you to reach out.
Thank you very much. Okay, we have the next one, Luca Musella from